Hi everyone, this video is going to be about Pythagoras Theorem and how to solve problems using it. Pythagoras is used in right-angled triangles where you know two sides but need to find out the third. Pythagoras Theorem states that in a right-angled triangle, a squared plus b squared equals c squared. C becomes your hypotenuse. A and B are your two other sides. The hypotenuse is the longest side out of all three sides of the triangle. The first example is if we have this right-angled triangle right here, which we know is right-angled from this square, we can say that if this length is 3 and this length is 4, what is this length? We know from what I previously said that the longest length, the hypotenuse, is always C. The other two lengths, A and B. It doesn't matter what length becomes A and what length becomes B, as long as it's not the longest length of the hypotenuse. Inserting these numbers 3 and 4 directly into our formula a squared plus b squared equals c squared, the formula now changes to 3 squared plus 4 squared equals c squared. All we have to do now to find c is to type this into your calculator. Or we can do it the longer way, which is 9, which is 3 squared, plus 16, which is 4 squared, will now equal c squared. Adding these together means that c squared is now equal to 25. Remember, 25 is not your final answer. What we want to find is c. Right now we have c squared. All we have to do now is to square root 25, which will give us c, which, if we bring it up here, is 5. That means that our final answer is 5 and c is 5. Referring back to our original, that means that 3 squared plus 4 squared equals 5 squared. An easier way of doing it on our calculator, instead of typing 3 squared plus 4 squared, which equals 25, then having to square root 25 like so, we can go straight to the answer by doing a square root bracket 3 squared plus 4 squared close bracket equals, which will directly give us the answer 5. That just makes it easier for when you have longer numbers and it's hard to do it all in the calculator in different stages. It does it all in one line for you. Let's try that with another equation. This one over here has the hypotenuse again marked x and the other two lengths marked 8 and 13. Remember to always label your sides before you start. We know x, the hypotenuse, will be c. And we know these other two lengths to be a and b. Again, it doesn't matter what one is a and what one is b, as long as it's not the hypotenuse. We then write our formula, a squared plus b squared equals c squared. And then we just substitute. So we get 13 squared plus 8 squared equals c squared. Doing this in our calculator gives us 233 as c squared. Now we know from before that 233 is not c and is not our final answer x. It is c squared. To find c instead of c squared, what we do, square root 233, which gives us 15.26. It's always good to give your answer in 2 decimal places. Again, on your calculator, it's easy to do it in one line by simply doing squared brackets 13 squared plus 8 squared and then pressing equals. and that will give us the same answer. Here, there's 3 practice questions you can do, all revolving around finding the hypotenuse. You can pause the video here to work on it before you continue on with the video. Here are the finished workings of the 3 questions. Feel free to again pause the video to look over them, check over your answers. A few things to mention is just remember that length C is also the same as length X, and that to always give your answer in units when units are provided. For example, in the first question, the question states that the lengths are 60 meters and 10 meters. That means that the final answer should be in meters as well. So you just learned how to find the hypotenuse in a right-angled triangle using Pythagoras Theorem. The next thing I'm going to cover is how to find a length that is not the hypotenuse. In this diagram, we see that the length of C, which is the hypotenuse, is already given, 21. And the other length, which could be A or B, is 12. The side marked X is not the hypotenuse and could be length A or B. To solve this, it is quite simple, but it is different from what we just did. Our original formula states that A squared plus B squared equals C squared. So we can start off by labeling this diagram like all the other ones. The hypotenuse, the longest side, is C. These 2 lengths can be either A or B. It doesn't matter. However, we can't use this formula in this direct way anymore. So what we'll do is just rearrange the formula. So for this diagram, what we're trying to find is A. Start with A here. What we'll do is move B squared over to where C squared is, so that A squared is the only number on that side of the equal sign. To do that, all we have to do is do the opposite to B squared, which is to minus B squared instead of plusing it. So what we'll do is just do C squared minus B squared. That gives us the formula A squared equals C squared minus B squared. So to answer this one, it's exactly the same as all the others. You substitute the numbers in. A squared equals 21 squared minus 12 squared. Put that into your calculator. You get A squared to equal 297. Square root 297 to find just A, which is 17.23. That means that A, or in this case X, equals 17.23. On a calculator, you do 21 squared minus 12 squared, bracket, and it'll give you the direct answer, which is 17.23. So that's how you find the length of A or B using Pythagoras when you already know the hypotenuse. Like before, there are 3 practice questions that you can use to test your skills. Feel free to pause the video and work on it before you continue watching. Here are the worked answers for the 3 questions. In all 3, I have written down C squared minus B squared equals A squared. It doesn't matter if you do C squared minus A squared equals B squared. If the B and A change around, it doesn't matter at all. So that comes to the end of this video. Hope you guys learned a lot. Make sure to check out the NCEA website to look at exemplars, past papers, and to get some practice questions. Hope you liked it.